Yeah, I think there might be two of the first slides, so you can go to, yeah. Perfect. So thank you for having me. As I said, my name is Harriet Bartlett, and I'm a researcher at the University of Oxford. And today I'm talking about two projects, but two sort of interrelated projects. And they're both on the theme of trade-offs and synergies or win-wins in our livestock systems, and promoting the best ways of farming for people, the planet, and the animals that we farm. So most of my talk, I'm going to talk about the top topic, which is biodiversity loss, greenhouse gas emissions, antimicrobial use, and animal welfare in UK and Brazilian pig systems, which was my PhD. And then I'll do a little bit on the next project, which is just starting, which is Brazilian beef with Jomana and Dennis. So if we can do next one. Perfect. So I'm going to start by talking about the background of the project and how this project came about, starting with land sparing and sharing, which I'll talk you through how we organize land for biodiversity and for food. Talk about the externalities framework and the main issues that we have with pig production. Then I'll talk about the aims of my PhD and the methods that I use, and then talk you through results. So starting with land sparing and land sharing. So this was really the sort of starting point of the research that I did, and it's how we farm in a way that's best for biodiversity. So if you have a set piece of land and an amount of food that you want to produce, there's essentially kind of two ways that you could organize it. So if we go to the next one. Perfect. You could use what we call land sharing, which is where you use, you overlap the land for food and the land for nature. They're both using that same space. You intersperse land for nature amongst food. Or we can use, and the next one, thank you, land sparing, where you separate the two. But how can we figure out which of these is best for biodiversity? Firstly, there's a really important consideration, and that's that land sharing reduces the yields of what you're farming. So you're producing less food per unit area, which means that it looks a bit more like the next one. You have a larger piece of land to produce the same amount of food. And next one. These are ones you're meant to just like click through. It's easier on the slide. So to figure out which is best, we look at what we call density yield curves. So you take a spectrum of habitat along the bottom. So this is intact habitat. You're not producing any food. At this end, you have the highest yield farming possible. You're producing the maximum amount of food you can produce on that land. And in the middle, we have land sharing, which is like intermediate yields. You've got land for nature and land for biodiversity. And so land sparing would be a combination of this one and this one, producing the same amount of food. And so then what you do is you go to this spectrum of habitats and you measure the abundance of different species. And so people in one of my PhD supervisors groups, his name's Andrew Barnford, have gone to 5 continents. They've done it in like 20, 30 countries. They've done it with trees, beetles, birds, mammals. They've done it with everything. And you look at the relationship between the density of individual species and this spectrum, or this like along the x-axis, the yield. And by looking at these relationships, you can see if, for example, this blue species really, really depends on intact habitat. As soon as you start producing any food, the density drops. So this is a really, really sort of land sparing, loving species because they really need this intact habitat. Whereas some other species do very well in farmland. So you can see this species here. Only when we get to very extreme high yield farming do we lose that species. And sorry, back, one more thing. And so they've done this on these 5 continents. They've done it on sort of 20, 30 countries, all these different species. And they find almost unanimously everywhere in the world, the best thing to do is land sparing. So use high yield farming. So you use less land to produce the food that we need and combine it with intact habitat, which is better for most species compared with land sharing. There are a couple of exceptions, and they're places that have had a long history of agriculture, like the UK, where you need some of this and some of this. But in Brazil, we know that it's true that really we need high yield farming and intact habitat for biodiversity because so much of your biodiversity depends on this. So we need to maximize that. So next slides, please. Thank you. But what about other things? It's not just biodiversity that we care about. And particularly that really high yield or intensive farming, people have lots of concerns about it. They're worried about animal welfare, they're worried about greenhouse gas emissions, infectious disease, all these other things. And it's assumed that intensive farms are worse in other ways. So there are what we call trade-offs. And at this stage, I should explain what I mean by costs. So this is language that's used in externality economics, and it basically just means a negative impact. So greenhouse gas emissions would be a greenhouse gas cost. It's not like a financial, it's not to do with money. A sequestration, so a net benefit, would be the opposite. So costs and benefits, depending on if it's positive or negative. Okay, next one, thank you. And so this is what I described. It's kind of assumed on this left-hand side, there's this trade-off. So as yield gets higher, which we know is better for biodiversity, other impacts get higher. So better for biodiversity, worse for greenhouse gas emissions, worse for animal welfare. And this is said in the literature a lot, but it's quite surprising how little evidence there really is to support it. It's just really an assumption. People don't really empirically test it. And so in a paper that we published, you can look up, oh God, 5 years ago now, we hypothesized that maybe this isn't the case because we haven't tested it. And maybe actually there are farms or ways of farming that are good in more than one way. Maybe it's possible to farm in a way that's high yield, so it's good for biodiversity, but also low greenhouse gas emissions, for example. And maybe also there's these systems that are bad in more than one way, the types of systems that we need to be avoiding. And so next one, please. And so in this study, we then looked for pre-existing data in the literature. And these are the plots just from our livestock systems. There's also some from the crop that you can see in the paper. And this is the only data, by the way, that we could find in the whole world on livestock systems that measured more than one impact. So they measured land use, and here we've got greenhouse gas emissions, nitrogen, phosphorus, soil. But the details aren't important of this, but what I want to show you is that we don't find these trade-offs. We don't find negative relationships where systems that are higher yield and better for biodiversity are worse. We actually find the opposite, that systems in general that were higher yield are also lower greenhouse gas emissions. They're lower nitrogen cost, lower soil cost. So we actually found the opposite. It's possible to have these kind of win-wins. There aren't these trade-offs. But next slide, please. Thank you. As I said, data is really, really limited. These are the only 6 plots we could do for the world's livestock systems. And people just aren't very good at measuring more than one thing. We tend to focus on one impact and don't think about the consequences for other things. And there was no usable data on monogastric systems, so our biggest livestock systems, pigs and poultry, no data on antibiotic use and resistance, and no data on animal welfare. And why is this a problem? Next slide, please. This is what I call the pig problem. Pig meat was the #1 most eaten meat in the world until African swine fever. Now it's #2, but you can see in pink, this is pig production across the whole world. It's massively expanded over time, as has poultry. And we're now producing more than 4 times the amount of meat globally than we produced in the 1960s. So it's massively, massively expanded. And by most predictions, this is going to continue, if not steepen, particularly for pigs and poultry. Next one, please. And pig production has a lot of sustainability challenges. So the first is biodiversity loss. So pigs and poultry are often thought to not use very much land. So biodiversity-wise, you think the impact is quite low. But actually, the vast majority of land use of pigs and poultry production is for feed, 99% or more a lot of the time. And this is really important because they consume a huge amount of feed. And it's estimated that by 2050, pigs and poultry will consume over 50% of the world's human edible grain. Next one, please. Greenhouse gas emissions. So pigs have lower greenhouse gas emissions or footprints than ruminants, so beef and lamb in particular. So a lot of people are saying we should be switching from beef and lamb to pigs, but pigs still have a substantial greenhouse gas footprint. They're 9% of the emissions from livestock. And again, most of this isn't from the pig farm, it's from the feed. 60% is from feed. And on average, across the whole world, 15% of the footprint of pork is from deforestation for soy. Next one, please. Antibiotic use and resistance is really worrying. Pigs are the highest users of antimicrobials on average across the world. On average, pigs use 173 milligrams per kilo. Chickens are about 140, and ruminants are way down at sort of 50 and lower. And again, this is predicted to increase exponentially. Next one, thank you. And on top of that, of course, animal welfare. These are highly sentient and intelligent animals, and they're often farmed in ways that don't take consideration of sort of their complex social behaviors, for example. So these were the challenges, the kind of gaps that informed my PhD. And my aims were, next one, please. Thank you. So I had 4 aims. Firstly, to quantify the greenhouse gas emissions or carbon footprints, the antimicrobial use, the animal welfare, and the land use as a proxy for biodiversity of a broad range of UK and Brazilian pig systems, and to look at these relationships between impacts. Are there trade-offs where farms that are good for biodiversity are worse for welfare or not? Identify the types of systems that are best if they exist. And then a last part of my work, which I'm not talking about today, we wrote a paper on the relative emerging infectious disease risks of different types of farms. And so I can always send that to you if you're interested in that. Next one, please. So onto the data. So I chose to study UK and Brazil because they're very complementary. They have very different types of pig farming systems. They're very different in farm size. Brazilian farms on average are much, much bigger. In the UK, outdoor production is very common. Actually, almost half of our breeding herd is outdoors, free range, whereas that's much less common in Brazil. In the UK, we can't use ractopamine. I know regulations have changed with that here too, but back when we collected the data, we did visit many farms that use ractopamine, but we're not allowed to do that in the UK. We also can't use gestation crates. They're illegal in the UK. We can use farrowing crates, but we can't use gestation crates. Antibiotic use, again, is very different. In the UK, you have to have a prescription from a vet every time you use an antibiotic. You can't buy those yourself. And feed is very, very different. In the UK, most pigs or pig farms that I went to were fed Brazilian soy in the UK, whereas obviously that's not the case in Brazil. You're not doing that import-export of feeds so much. Okay, next one, please. And so I'm going to focus on showing you the results from the UK, but the results from Brazil are pretty much identical. I just got a bit more data from the UK because COVID happened during the second time we were collecting data in Brazil. So this is data from 74 breed to finish systems. So these are like complete cycles. And each of these is made up of between 1 and 3 farms. So sometimes a complete system is 3 separate farms because you have breeding, like a creche, and then you have termination. And so you can categorize farms in lots of different ways. And this is categorization by certification schemes. In the UK, we have a lot of certification schemes, and you can see they overlap. So as a summary, none, they have no certification schemes. It's just kind of minimum UK standards. The next most strict is Red Tractor, which is really used just as a UK, like it identifies that it was produced in the UK, but there are some traceability standards there. Next, RSPCA Assured. So here, a sow has to always be able to turn around. So it can be indoors, but you can't have the very restrictive farrowing crates. And finishing pigs have to have access to some enrichment. Free range is completely outdoors. Woodland, outdoors, and you have trees. And then organic has to be free range, and you have these extra requirements, like you can't dock tails, you can't give antibiotics more than 3 times a year, and you have to have special permissions from a vet to give antibiotics. And you can't use genetically modified feed is the other thing for organic. Next one, please. Thank you. So now I'm going to talk you through my methods to quantify each of my 4 impacts. Again, the cost, it's not like a financial, it's nothing to do with money, it's just a negative impact. So I recruited farms all the way from these indoor intensive through to organic. And I tried my best to minimize bias. It's almost impossible because there's no database of all farmers. So the best I could do was to use people within the industry to help recruit those types of farms that are much harder to recruit. And to collect my data, I conducted a questionnaire on the farms. I did welfare assessments on the farms, and every farmer was offered optional feedback on their performance, and all of them have asked for it, which is really good. And all of these are measured as land use per kilogram dead weight, so a measure of pork. Next one, please. Thank you. So the land cost, this has two components. It has the area that's occupied by the pigs, and the next one, please. But most important is the land for feed. And so to calculate this, I asked farmers for information on how much they have fed and the formulations of all the feeds. And for one farm, this was often more than 300 different data points. So it's very, very complex data. And I used a life cycle assessment tool, which is called FeedPrint, to calculate the land use required to produce the feed. And as I said before, this is often more than 99% of the footprint. So actually, this should be much, much smaller, and that should be bigger. And this is the results of what land use looks like. So this is the meters squared to produce 1 kilo of pork. And these are these different labels that I described. So none is no certification, as they get stricter all the way to organic. And these are the types of like husbandry. So indoor, hybrid, indoor, outdoor, and outdoor breeding. And then finishing, slatted and straw and outdoor and outdoor. And you can see that organic is significantly higher than all these three types and much higher than the others. And so that means, in general, we think it's worse for biodiversity because you need so much more land to produce a kilo of pork. Next one, please. And so greenhouse gas emissions, I estimated this by, again, collecting a lot of information on a questionnaire on the animals, like the types of animals, their weights, when they buy them, when they sell them, what they eat, how they manage the manure. You take a lot of information about management, and you can calculate the emissions associated with all of these different things, all the way from producing the seeds and fertilizer that go into the feed, through producing the animals, feed processing, all the way getting down, and I went all the way to slaughter. And next. And these are the results from that, which look almost identical to land use, you'll see. So again, they increase, and organic has much, much higher footprints than the others and is significantly higher than these three. So again, that's worse for the climate because they're much less efficient systems. You need a lot more feed to produce a kilo of product. Next one, please. So welfare cost was a little bit more complicated, and we had to come up with our own metrics so that we could put it into this kind of way of comparing farms per kilo of pork. And so most metrics focus on quality of life, but different systems require different quantities of life years to produce a unit of product. And I'd argue that it's important to consider time as well as quality of life. If you have two farms that have a poor quality of life, they're identically poor, but one requires twice as many animal life years to experience that to produce a kilo of product, that should be accounted for in our welfare metrics too. So we came up with new metrics or adjusted existing metrics. They're based on welfare quality, which looks like this. And so this is a summary of one of the two protocols. This is the fattening pigs. Sorry, it's a bit small. There's a separate one that you do for sows and piglets. And just as an example, if we follow from this side, I would look at the percentage of very lean pigs on the farm, so body conditioning score. You do some like stats, and then you have sort of different ways of integrating multiple measures into these 4 different principal scores. And they're all out of 100, and you have good feeding, good housing, good health, good behavior. And in these boxes shows all the things that you measure. So it's about 30 things in general that you randomly do across the farm. So I did this for breeding farms and for finishing farms for each of my data points. But there are sort of 2 big limitations of welfare quality. Firstly, you end up with 4 scores per protocol. You get 1 score for feeding, 1 for housing, 1 for health, and 1 for behavior. And there's no established way of integrating these into a single score. And secondly, they don't account for time still. So that was the other limitation. So what we did is we essentially tested different ways of dealing with these problems. So the next one, please. So this is basically like a sensitivity analysis. You can see these are the different labels along the bottom, and each of these grid takes a different threshold of quality of life for it to be a good thing to prolong the life or a good thing to shorten the life, which is a very controversial thing to say. Like, this quality of life is poor enough that actually it's kinder to welfare to reduce the length of time animals are experiencing it. And it's something that I think is impossible to decide because it depends on so many different factors. But fortunately, from our sensitivity analysis, we find that it doesn't matter which one you choose. So it's not an argument that we need to have at this stage. And the different colors for each show different ways of weighting welfare quality principles into one. So one is just treating them equally. Another one is treating health slightly more important than the others. And then a third one is doing that even to a greater extreme. And we find really it remarkably makes no difference. You can see within, like there's really very little difference between the three colors for each label. So again, this is something we find people argue about and find very controversial to say, is health more important than behavior? We find when you actually do the maths, it doesn't make a difference. So you don't have to decide. And the next slide, please. And so that's by label. This is just showing individual farms, and it shows different metrics again, and we find that they're highly intercorrelated. So if you're looking at labels or you're looking at individual farms, it doesn't matter how you choose to construct your metrics. The same farms are consistently the best, and the same farms are consistently the worst. Okay, next, antibiotic cost. So this, we collected information by a questionnaire and getting information on the feed as well, because a lot of antibiotics are in feed. And I calculated the annual use in feed, in water, and injectables. And we took these fecal samples, but we've had problems with them, so ignore that part. And there are lots of different metrics for quantifying antibiotic use. And so what I did is I calculated all of them, and I found, again, it doesn't matter which one you choose, the same farms are good and the same farms are bad, with one exception. So next slide, please. So if we focus on this one first, this is total antimicrobial use, so the milligrams of active ingredient per kilo of pork. And you can see there weren't significant differences. Within all of these different categories, there are some farms that use 0, no matter what, even the most intensive ones. But going back to metrics for a second, the one metric that didn't intercorrelate was critically important antimicrobials. And so these are called in Europe category B antimicrobials. And so the use of category B antimicrobials didn't correlate with total use. So the most important ones for human health tend to be very lightweight. And so the metrics we use overall often don't recognize this. So we say the most important thing is to report total use and then separate out the critically important ones. Because you can see these farms look very good, but here they have the highest use of the critically important ones because they're so light. It's 0.3 compared to 300. And these are things potentially like last line antibiotics for human medicine, like the really critically important ones that we need to stop use in livestock. Okay. And now onto the results. So looking at multiple impacts at the same time. So I just want you to remind you of the kind of framework, which is looking at more than one impact. And the general assumption is that systems that are intensive, pig farms that are intensive, have lower carbon footprints, but poorer welfare and higher antibiotic use. That's something that's said in the literature, it's said in the newspapers a lot. So onto the results. So firstly, we found some good news, which is positive relationships. So land use, biodiversity, and carbon have a very strong positive relationship. So farms that are good for one are good for the other. And that's because of this land use for feed, really. That's the main predictor of that. And then the other, sort of, it's less convincing, but it is still a positive relationship, was antimicrobial use and animal welfare. In general, the farms that used less antimicrobial use had better welfare. And then on to the bad news. We also found lots of trade-offs. So unfortunately, land use and antimicrobial use, greenhouse gas emissions and antimicrobial use, land use and animal welfare, and greenhouse gas emissions and animal welfare were negative, so trade-offs. Farms that were good for one were bad for the other, and vice versa. But this doesn't sort of convey the whole picture. And now what I've done is I've zoomed in on the best 50% by each impact, and you can see that those trade-offs aren't the whole story, because in all these plots, we have farms that are good in the best performing 50% by both impacts. You can see that there's lots for greenhouse gas emissions and land use, and lots for where we had these two positive relationships, but a lot less, particularly for things like land use and animal welfare. There's like a stronger trade-off there, but there are these exceptional farms that manage to achieve low impacts in both. And there were actually 5 farms that were, sorry, one more on the one above. Thank you. There were actually 5 farms that were in the best 50% for all 4 impacts. And these were very different farms, which is something that surprises people. So one was a woodland farm with trees outdoors, completely free range. One was the most intensive farm that we have in the UK, so slatted floors, farrowing crates, completely indoor. And 3 were sort of hybrids, one partly outdoor, partly indoor. And no matter how much I look at my data, I can't find something that predicts these farms, which is frustrating, but also I think really interesting that such different farms can achieve these low impacts. The only ones that didn't get there were organic, because no organic farms had low enough carbon footprints and land uses, and no free range as well, again, because of the carbon footprint and land use. Now on to Brazil. Next one, please. Thank you. So you can see there's less data points, so the stats are a bit less convincing. But in general, we don't find anything that contradicts what we found in the UK. We find, again, a really strong positive association between greenhouse gas emissions and land use, biodiversity. And the others are a bit less convincing, but interesting that we don't get these trade-offs. We get these kind of clouds of points where there are some farms that are low carbon and good animal welfare, for example. There we go. Next one. Oh, yeah, thank you. And so this is the, do I have one more? No, I don't, sorry. Well, the previous one again, thank you. And again, with this, we found that there were several farms that are in the best performing 50% for all 4 impacts. Okay, next one. Thank you. So the conclusions are that there's this win-win for greenhouse gas emissions and land use, which is biodiversity. And the same, we find there's a win-win for antimicrobial use and animal welfare. But there are trade-offs between those pairs. If you're good for land use, you're good for greenhouse gas emissions, but you're bad for welfare and bad for antimicrobial use. But fortunately, they don't appear to be inevitable. There are farms that manage to kind of break that rule and be good for all 4 things. But nothing predicts these. So if you're saying we need to change our farming systems by husbandry type or certification scheme, then the evidence doesn't align that that's going to help. Okay, next. So before I get onto the beef, I just want to thank the people involved in this. Lots of people in here and on the call, my funders, and of course, all the pig producers that generously gave us their time. And now briefly, I'm going to talk about the Brazilian beef project. So next one, please. Thank you. So a project I've got going on back in the UK, or I'm starting to try and do, is to help pig producers improve. When we've sorted that out, we want to do that in Brazil too. But the exciting next project which Germana and Dennis are involved in is sort of upping the ambition and applying this kind of framework to Brazilian beef, but in a much more ambitious and broad way. So we're not just looking at greenhouse gas emissions, biodiversity, animal welfare, antimicrobials, we're also looking at emerging infectious disease risk, so viral spillover risk. And our goal is to look at a broad range of Brazilian beef systems, quantify these different impacts, and again, see if we have these trade-offs or not. And funding dependent, we then want to run a trial on these farms. If we give farmers access to information about their impacts, compared with their neighbors, compared with an optimal farm, does that change their behavior and does that help them to improve? Thank you. Any questions? Any questions?
The antimicrobial use in UK and Brazil, what are the differences or similarities?
In the amounts or practices, or both?
Both, amount, practice, the type of products used.
Okay. So there wasn't a significant difference between antimicrobial use in the UK and Brazil, but that could have been because of our sample size in Brazil as well. But the average is lower in the UK than in Brazil. And then in terms of practices, in the UK, you have to have a prescription from a vet, but you can get a prescription from a vet for in water and in-feed antimicrobials that are really, really high use. So it doesn't necessarily mean you've got lower use. It just means there's a little barrier there. And there were some antimicrobials used in Brazil at the time, which again, I think have changed since, like colistin, which aren't allowed to be used in the UK. Yes?
I would like to know what impact of the GMOs in the biodiversity, as well as in the UK is prohibited. And you just said that we use our soybeans, so it means that it is prohibited, but Even though you're
Yeah. I think it's very hypocritical, if I'm honest.
so
Yeah.
why?
Yeah. So did everyone hear the question? Yeah, about like GMOs and importing them versus but not growing them in the UK. So, I mean, the first thing to say is this could be changing in the UK. It could be one of the good things that happens after Brexit, because there are discussions now to change this in the UK so that we can use GMO crops. Who knows if it will happen? There are a lot of people that are really opposed to it, but public knowledge is very low on this. People really don't understand. There are a lot of people that are really opposed to GMOs that eat pork that's been fed with GMOs. So I think that's a real barrier to the changes as well.
Does it impact the biodiversity?
So any land use, so I calculate the land use as a proxy for biodiversity. And that does, I count the land in Brazil and the land in the UK if that's producing UK pigs. So it does, yeah. But if you were to compare GMO to non-GMO, GMO is higher yields, so it's better for biodiversity because it uses so much less land. Yields can be doubled sometimes, if not more. So that means you have less land to produce the food, so you can have more land for nature. So actually, in general, GMOs are thought to be better for biodiversity. Yeah.
It's interesting because the propaganda, they say that the organic food is more better for the environment. It has more gas emission and more land use.
Yeah.
So it's the opposite, actually.
It is, yeah. The exceptions, I've been looking at other foods, not just livestock. Salads can be relatively equal, organic and non-organic. So like colleagues that I have, the experts on this, they eat organic salads and not organic anything else. Okay. So that's grains. There's a big difference where organic is much, much lower yield. So uses a lot more land. And I think potatoes on average are 10 times the carbon footprint for organic than conventional. Like huge difference, yeah. Like organic potatoes are almost like beef, like really crazy, yeah.
Hi, thank you for bringing us this lecture. It's very exciting how you put everything together, and I think it was a huge challenge to think how to put it together and make understandable. I have a question regarding the welfare measures that you use. Something that concerned me about the measures that we have about welfare is that most of them is like a kind of picture of the welfare. It's acute. We don't know how their experience is in terms of welfare. How do you think it could impact if we at some point we have over time welfare measures? How do you think will impact this on the other measures that you have, like regarding antibiotics or sustainability or use of land?
Yeah, good question. Thank you. So all the welfare assessments I did are snapshots. I did welfare quality assessments on one day on each farm. And so I sort of have to assume that day was representative. By having lots of farms in the same category, that should buffer the error that I have there. And welfare quality tries, where it can, to use indicators of long-term welfare. So looking at outcomes on the animals rather than things in the environment that can be changed. And so a snapshot wouldn't be representative. You try to look and particularly score things worse if they're going to affect welfare negatively for a long time rather than a short amount of time. I think these like new technologies that are coming through that allow us to monitor welfare constantly, like Marion Dawkins in Oxford is working on things in chickens that are like 24/7 monitors of animal welfare, are really exciting. And those same types of technologies can be used to inform land use, greenhouse gas emissions, how we collect all this other data too. So I think there's kind of technological win-wins. But if we were able to measure welfare over long periods of time, I don't know that would change any of the results in terms of like the trade-offs and the win-wins. I don't think it would. I hope it wouldn't, but we don't know. I hope that answered your question.
Thank you. Yeah, it's hard. Thank you.
Good. You're welcome. Thank you.
That's good. That's good. Thank you very much.
See you next week. Now, drink coffee.
Now, yeah, that's the way. Coffee, though. An ice cream. You have ice cream.
Ice cream.
No, it's not necessary.
Yeah.
I say it's-
Yeah. To be more precise.
Necessary is, ice cream.